Assalamualaikum. In today's episode, we look into the two conditions for total internal reflection to take place. So join me till the end of this video lesson. Just stick around, what you learn. Question is, a beam of light is propagating through diamond and strikes the diamond air interface at an angle of incidence of 28.0 degrees. Question letter A. Will part of the beam enter the air, or will there be total internal reflection? Question letter B. Repeat part A, assuming that the diamond is surrounded by water. Use the refractive index for diamond equal to 2.40, 1.00 for air, and 1.33 for water. The light beam is propagating from medium 1, or within the piece of a diamond, forming an angle of incidence theta 1 equal to 28.0 degrees at the diamond air interface. And the question is, will part of the beam enter the air, or will there be total internal reflection? For there to have total internal reflection, two conditions have to be satisfied. Number one, the refractive index of the first medium must be greater than the refractive index of the second medium. And the second requirement is that the angle of incidence must be greater than what we call the critical angle of the first medium relative to the second medium. And in this problem, we are given the first medium to be the diamond whose index of refraction n sub 1 equals 2.40, while the second medium is air with an index of refraction n sub 2 equal to 1.00. Alright? So, looks like that the first condition is satisfied because the index of refraction of diamond is greater than the index of refraction of air. Now, to find out if the second condition is also satisfied, we have to compute the critical angle theta I of diamond relative to air. And the formula is the critical angle is just equal to the arc sine of the quantity index of refraction of air over the index of refraction of diamond. That is arc sine of quantity 1.00 over 2.40. So using your scientific calculator, we find that the critical angle of diamond relative to air is equal to 24.6 degrees. And since the angle of incidence theta I is 28.0 degrees, which is greater than the critical angle of diamond relative to air, then we say that there will be total internal reflection that will occur at the diamond-air interface. And as shown in this diagram, the angle of reflection or total internal reflection is just the same as the angle of incidence, following the law of reflection. For question letter B, what if the diamond is immersed in water? Will there still be total internal reflection? All right. So this time, the second medium is water, whose index of refraction, n sub 3, is equal to 1.33. And that of the first medium, or diamond, is 2.40. So, still the first condition for total internal reflection to take place is also satisfied. All right? But computing the critical angle of diamond relative to water, all right, using the same formula, we have arc sine of the index of refraction of water 1.33 divided by the index of refraction of diamond 2.40. So again, using your scientific calculator, we will get the critical angle of diamond relative to water uh, equal to 33.7 degrees. All right? And since the angle of incidence is 28.0 degrees Celsius, which is lower than that of the critical angle, so our conclusion is that there will be no internal reflection happening at the diamond-water interface. Okay? Instead, the beam of light emerges into the water medium, and in fact, it gets refracted away from the normal. Right? So we emphasize that here in our diagram. All right? The light beam is able to emerge from the piece of diamond into the water, right? With its refracted ray bent away from the normal, which suggests that the angle of refraction, okay, is greater than that of the angle of incidence. And in just a short while, we're going to compute this angle of refraction of the light beam. All right, so we're going to compute the angle of refraction of the emerging beam of light. All right, the beam of light that was refracted is bent away from the normal. So, to determine the angle of refraction, we apply here what we call Snell's law of refraction, whose mathematical equation is sine of the angle of incidence multiplied by the refractive index of medium 1 is just equal to sine of the angle of refraction multiplied by the index of refraction of the second medium. All right? N1 pertains to the index of refraction of diamond, while N3 pertains to the index of refraction of water. All right? So, substituting the quantities and isolating sine of the angle of refraction, theta sub r prime, that is the symbol for our unknown variable. Okay, the angle of refraction, theta r prime. All right, so sine of 28.0 degrees is multiplied to the index of refraction of diamond, or 2.40, and then their product will be divided by the index of refraction of water, or 1.33. So when we do our math, all right, getting the sine value of 28.0 degrees, which is 0.469. All right. And finally, we come up with the angle of refraction, theta r prime, equal to 57.8 degrees in three significant figures. All right. So as emphasized in the drawing, this angle of refraction is much larger than the angle of incidence, as expected. So that's it. We're done. Till the next episode. Mabuhay. Mashallah. Thank you very much for watching. Please follow me in my FB page, Watch and Learn. And please don't forget to subscribe to my YouTube channel.